Hello everyone. And there is a heat engine with the efficiency of 0.2 and the ideal gas changes according to this direction clockwise. So from A to B and C to D, pressure is constant. And from B to C and D to A, temperature is constant. From B to C, the amount of work a gas does or receives is 2 times W. From D to A, the amount of work the gas does or receives is W. Because ideal gas is used, or we can use ideal gas equation. For PV is equal to nRT. So in the state of D, if the pressure is P0 and temperature is T0, let's say the volume at the state is V0. In such case, in state A, when pressure doubles, volume is half. So at the constant temperature, so the volume of A is 1/2 of V0. And the volume of B is V0, and volume at C, when temperature doubles at the constant pressure, volume also doubles. So volume at C is 2 times V0. So we can make the graph of volume and pressure of this gas. So at state D, volume is V0, and pressure is P0. And in state A, when pressure doubles, volume is half. So state A is this position. And the temperature doesn't change, so this curve indicates T0. And from A to B, the volume changes from half of V0 to V0, and pressure is 2P0. So this dot is for B. And in state C, volume is 2 times V0 and pressure is P0. So from B to C, at the constant temperature, this curve follows 2 times T0. And according to the first law of thermodynamics, the amount of heat is equal to the change in the energy of the gas plus the amount of work. So let's make a table for these three quantities. So Q delta U and W from A to B, B to C, C to D, and D to A, and the net total. And from the problem, from B to C, as the volume increases, the gas does work, and the amount is 2 times W. And from D to A, as the volume decreases, the gas receives work, and that means the amount of work and the sign is negative W. And from A to B, the area of the graph PMV is the amount of work. So if we calculate the area of this rectangle, that's 2p0 times half of v0. So the amount of work is p0 times v0, and as the gas expands, the gas does the work. And from C to D, if we calculate the amount of the area of this rectangle, the height of the rectangle is p0 and the width of the rectangle is v0. And as the gas compresses, that means the gas receives the work. So at first, the total amount of work after this cycle is W. And because the efficiency of this heat engine is 0.2, the engine absorbs heat of 5 times W. And from B to C and D to A, when temperature is constant, the energy of the heat doesn't change. So this delta U is 0 at these two processes. That means to do the amount of work 2W from B to C, the engine needs to absorb the 2 times W amount of heat. And from D to A, the engine releases the amount of heat minus releases the amount of heat at the W, because the energy change is 0 to satisfy this equation. And after this cycle, the amount in the change of energy should be 0. That means the total amount of heat absorbs is W.